Hello, Curly Salali here. In this video, we're going to take a look at repetition structures, immensely powerful and useful tools in any programming language, and PowerShell is no exception. So previously, we've looked at data types, storing values in variables and retrieving them and manipulating that data. We've looked at decision structures, if and else, and switch statements. And we've looked at different types of operators, logical operators, comparison operators, mathematical operators, different methods that we can use and functions with decision structures. The next thing that we need to cover in this series is repetition structures. This is how we do looping in a language. So again, I'm just going to open up ICE and we're going to go through some basic repetition structures in PowerShell. Okay, so repetition structures, they give you the ability to do a lot with a small amount of code. When you can iterate and repeat something, dozens of times or hundreds or thousands of times, then in just a few lines of code, it can be very powerful, especially when you combine them with things like arrays and array lists and custom-built objects. So a very basic for loop, we'll take this as an example, and I'm going to just add a couple of lines here. And that'll be our code, and add a couple of more lines here. Okay, so very basic for loop in PowerShell starts with the keyword for, and then the action portion of this loop is going to be inside an open and closing set of parentheses, okay? And so the very first part of a for loop, you're going to initialize a variable to a value. This could be anything. I'm calling it X, Y, Z. It could be banana, whatever you wanted to call it. But in this case, X is initialized to start out at 0. Then there will be a test condition portion of that for loop. So after the semicolon, I'm going to have is X less than 5. So basically, I'm saying I want this loop to continue as long as X is less than 5, as long as this portion is true here between the two semicolons. And then this last portion in a for loop is the action portion. So I'm doing a postfix increment here on my variable. So again, what are we saying in this for loop? We're saying any variable, initialize it with a value. It's usually 0, but it could be some other value. A semicolon, all right, so this is the initialization portion of a for loop. This is the test condition portion. So I want it to loop while X is less than 5. When that's no longer true, when X is equal to 5 or greater than 5, we will break out of the loop or fall out of the loop. And then this last part, I'm simply postfix incrementing. So I'm just going to keep adding 1 to X. So, X starts out at 0, I loop, and this just means adding 1. Matter of fact, I guess I didn't go over that, but I should. So an increment, especially like a postfix increment, if I say this to the variable X, it's a shorthand method of saying this, or it's the exact same as me typing this out in code. If I assign X as equal to itself, see what I'm saying? So this is what we call a postfix increment, but this operator here, it's equivalent to me saying X is equal to X plus 1. So whatever it is, I'm just adding 1 to it. But you'll see this a lot in for loops, and I apologize if I didn't cover that before. I guess I didn't. So basic for loop, remember initialization phase, the test condition portion of the loop. In this case, as long as X is less than 5. And then what do we do each time we iterate through or cycle through the loop? In this case, we're just going to add 1. So if I were to run this code, see what happens? Iteration 1, 2, 3, 4, 5. In the loop. Now, notice this right statement here. And why am I adding 1 to x? You know? Well, because if I didn't, look what happens. 0, 1, 2, 3, 4. And remember we had talked about this earlier in previous videos, the off by 1 issue, or the what's called the fence post issue. That's because computationally we start counting at 0. We don't start counting at 1. So something, 5 objects or 5 elements, when we, in later videos when we talk about arrays, it wouldn't be indexed or have a subscript value of 1 through 5. It would be indexed or have a subscript value of 0 through 4. It's still 5 elements, but you start at 0 and not at 1. And so sometimes that introduces logic errors into your code. If you don't think that way, you need to sort of learn to think the way the computer does. Think the way that PowerShell does. And the way that PowerShell thinks is we start counting at 0. We don't start counting at 1. So to make our programs more user-friendly, or to make the output more user-friendly to people that aren't used to thinking from a programming perspective or programmatically, then in this case, we would add 1. And if I do that, now I'm counting 1, 2, 3, 4, 5, okay? So any code that I put between this opening brace and this closing brace, that code's going to be repeated how many times? As long as x is less than 5, x starts at 0, so 0, 1, let me go here, 0, 1, 2, 3, 4, that many times, okay? So basic for loop, these are used a lot in programming, and it's probably one of my favorite repetition structures. I don't tend to, I use while true loops sometimes, and we'll look at those, and every once in a blue moon, maybe I do while, but for the most part, I use for loops in my scripts just because they're very versatile. You can put other things here in the parentheses portion. I could call a function or a method, and it could be like 100 lines of code, and it could execute 100 lines of code, and then when it gets done, it returns a value. And the value that gets returned, I could put that in the test, portion of my for loop. So to me, this is probably one of the most versatile and simple types of repetition structures. But we'll look at some other repetition structures as well in PowerShell, and look at different reasons you might use them. So basic for loop. Here is our for loop 2. Let's take a look at what this code does over here. We'll throw it into our test area. So what are we saying? We initialize x to be 0 while x is less than 5. And it's a postfix increment, right? So x is equal to x plus 1. So what are we doing here? We're writing output, and then output is equal to output plus, well, this is what we call an accumulator, this operation here. And let me go ahead and I'm going to add the PowerShell word clear here. So when we run this, it'll clear things out a bit. Okay, so basically just with that little asterisk, sort of draws out an ASCII, I guess, isosceles triangle. Okay. Remember what we were talking about, though? When we have an accumulator, when we're implementing accumulation in a variable, I could, if I wanted to, couldn't we do that? This overloaded, addition and assignment operator would that give us the same net effect? Absolutely. Okay. It's a matter of preference. I'm not going to tell you either way is right or wrong, but sometimes I think this is less work. Maybe it's more efficient because it's less typing. It's not more efficient in terms of how it's interpreted or the resources that it uses, but I just want you to see that you have options and that there's always several a multiplicity of ways of doing things in terms of coding. And sometimes it just boils down to style. You can compare one person's painting style or drawing style to another. You can't really say that this person's style is right and that person's style is wrong, sort of a matter of interpretation, right? And that person's style. So, I mean, there are some aspects of programming that are like that. There are definitely some things that are flat out wrong, logic errors and syntax errors and things like that. But when it comes to translating your thoughts into code, or coding out logic, there's got to be sometimes more than a dozen different ways to do something, a dozen different equivalent ways to do something. And so then it boils down sort of to a matter of personal style. Okay, so now we're going to do a nested for loop. Remember we looked at nested if, else, and else if structures, and we talked about nesting one decision structure inside of another. We can do the same thing with repetition structures. You'll see that a lot. You'll see one for loop. In this case, we have this inner for loop nested inside of an outer for loop, okay? And here we represent rows and columns. And this will become much more interesting when we combine these repetition structures with arrays. It creates a very powerful combination tool, right, or combination move in PowerShell. So that's something that you might see here, but let's go ahead and run this. Okay, now if you look for every iteration of this outer loop, right, from this brace to this brace, for every single iteration of this outer loop, which is less than rows, so what is rows? 5. So 0, 1, 2, 3, 4, this outer loop's gonna repeat 5 times, right? It's gonna iterate 5 times. Well, for every iteration or repetition of that outer for loop, this inner for loop itself is going to iterate how many times? Starts out at 0, y starts out at 0, while it's less than columns, which is 10. So this is going to loop 5 times on the outside, and each time it loops, this is going to loop 10 times on the inside. Do you see? And so, row would stay the same 10 times, but column is going to be modified because row is represented by x plus 1. Well, x doesn't get that increment until we get done looping these 10 times here on this inner for loop. Then it ends, and then it goes to the outer for loop, and x increments, and so that increases the value of x by 1. But for every single, iteration or repetition where we increase the value of x 1 time, we're going to increase the value of y inside of that repetition or inside of that loop 10 times for each one. And so that's why you see this output here, right? You see row 1 stays the same for 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Row 2, 1 through 10. Row 3, 1 through 10. Row 4, 1 through 10. Row 5, 1 through 10. Okay, so does that seem logical to you? Does that make sense to you? And do you see why we're adding the 1 here? We're adding the 1 because, if we didn't, what would happen? Well, we wouldn't start counting from 1 to 10. We start counting from 0 to 9. That's how the computer thinks. That's how PowerShell thinks. But that's not how human beings think. So a lot of times in situations like this, you'll add 1 to the value of something, especially like a nested loops or nested repetition structures, to make the output a bit more, to humanize it, or to make it a bit more human friendly. But again, if we were to pull those out, then let's see what things really look like under the hood in PowerShell. So you can see, right? Row 0, 1, 2, 3, 4, still 5 rows, but they're numbered from 0 to 4 rather than 1 to 5. And the columns, still 10, but it's no longer numbered 1 through 10, it's numbered 0 through 9. Okay? And we'll undo our changes, and there you go again. So rows 1 through 5, and each row has 10 columns. All right. So again, are you following how this works? And if this is your 10th programming language, this is a piece of cake for you. You're like, Carly, this is boring. Move on, hurry. But for those of you who, if this is your first scripting language, your first programming language, I want these things to become second nature to you. And this is also something I'd like you to, rather than just watch me highlight things and type a few characters in ICE, take this code, type it into ICE, pause the video if you need to, and I'll put some source up under here a bit. But type it in, break it, fix it a few times, modify it, change it, play with it, play with the code. You can't hurt anything. We're not connecting to production resources or Exchange or actively. So you can crash it. You can make all kinds of errors, and because we're keeping it agnostic and we're just focusing on the language right now, this is sort of your honeymoon with PowerShell, and you can get away with all kinds of things without having to be careful. So in this case, just kind of want you to get a feel for how the program flow works, right? So we have an outer for loop and an inner for loop. And for every outer iteration or repetition, this inner for loop is going to loop 10 times. Okay? All right, so let's take a look at our next example. And this time we're going to do the ForEach loop, right? ForEach loop is very useful a lot of times when you get a return value from a commandlet in PowerShell. It comes to you in the form of an array of different objects or different elements. And in the same way that a variable holds a value, you can think of an array as a special kind of variable that holds multiple variables inside of it. Okay, so if a variable is like a box, then an array is like a box that holds several boxes. Like, you ever see one of those Japanese bento boxes, that you put lunch in, like sushi, or a pillbox. If you're middle-aged, I'm sure you know what those are. Yikes. But, basically a box divided up into compartments, or a box that holds other boxes. So that's what you can think of an array as. Well, a ForEach loop is very useful for something like that. And so as an example of a ForEach loop, and again, we're trying to eat this elephant one bite at a time, so we will talk a lot more about arrays in a future video dedicated just to arrays. So for now, just kind of throw that up there in the gray area where, okay, that's, if that's a little fuzzy to you, or that's something we'll talk about later in more detail, but for now, just sort of a, very brief summary of what an array object is. So in this case, this is what we're doing. We're building an array, okay, which is just a special variable. It's a variable that holds multiple other variables. And so here we have all these strings, right? String variables. Twilight Sparkle, Fluttershy, Rainbow Dash, Applejack, Rarity, Pinkie Pie. 6 strings are held inside of this array, MLP underscore main underscore characters. We have another variable, a pony counter, right? And it starts out as 0. It's just an integer. So here's our ForEach loop. It uses the keyword for each. And then inside the parentheses, this could be anything. I could call that banana. I could name that X, B, Y, whatever I want to call it. Supercalifragilistic. It doesn't matter. It doesn't really care what you call it, but it knows that if you use an array of objects, in this case MLP main characters, and it can count, all right, the number of objects stored inside that array. There's even a special count method we'll go over later that's very useful. Then it knows to iterate until it gets to the end of the array. So how many times would this ForEach loop repeat itself or iterate? Well, count the number of elements in the array. So you have 1 string, 2 string, 3 string, 4, 5, 6. There's 6 strings in this array. So it would iterate or loop 6 different times, right? Pony, so for every pony, for every element, every string stored in MLP main characters, do what? Increment the variable pony counter. So we just add 1 to it. And we're going to write character, and then this will be the numerical value of pony counter is, and then the pony. So let's run this. Character 1 is Twilight Sparkle. Character 2 is Fluttershy. Character 3 is Rainbow Dash. Character 4 is Applejack. Character 5 is Rarity. Character 6 is Pinkie Pie. Okay? Do you follow? We could, this doesn't have to be pony. It's logical because they are ponies, but let's say we wanted to make it a banana. As long as I also made that a banana. PowerShell doesn't care what I call this. This could be anything you want to call it. It just knows that this represents a single element. And an element is like a unit or a box stored inside of the outer box that is the array. So again, if you think of an array as a box with separate compartments in it, like a pillbox or a bento box, or if you think of it as a box that holds other boxes, then these would be the individual boxes held inside of the outer box MLP main characters. So whatever we call this, that represents one of those compartments, one of those boxes inside of this box of boxes, or this box of partitioned containers. Does that make sense? So again, as banana, it does the same thing. What if we made that a supercalifragilistic, expialidocious? I'm not going to go that far, but we'll make Mary Poppins happy. Same thing. It doesn't matter. You understand? But because pony would be logical, normally when you're coding, if you name your variables and your elements and your objects creatively, it can greatly reduce the amount of documentation and comments you have to add to a script or program. You should always document your program to make your code easier to maintain. Or so if somebody's going through your code that didn't write it, try to explain what it is you're doing in the code and why. And you can add that in comment tags, but also sometimes just what you name something, that makes sense, right? If this is a group of ponies, 6 ponies, the My Little Pony Friendship is Magic main characters, the 6 main characters, makes some logical sense to just call each individual pony a pony, right? And so we can do that. So, not important what you name this, but PowerShell understands because of the order and the sequence, because this comes before the array, and because it sees the keyword for each and the test condition in parentheses, it knows what to do. It knows that this represents one variable held or stored inside that array of objects. Okay? Okay. So now let's look at a basic while loop. Now these are great when you want something to keep looping until a certain condition is met. I use them a lot when I'm building a menu in the console, or when I'm checking repetitively, sometimes thousands of times, or maybe for a script that I'll run in the background indefinitely. Situations like that are great for a while true loop. While true loop's just going to keep repeating forever until a certain condition is met, which we would plug into the parentheses here. So I have a lucky number, 444. I have a counter. What am I going to do? While true. Just uses the keyword while, an open and closing brace. So any code that I put between this open and closing brace is going to be repeated, or to iterate until while encounters some condition that would make this appear false. All right. So when we start out, counter is 0. Lucky number is 444. For as long as counter is what? Less than lucky number, I want to keep this code repeating. I want this to keep iterating. What happens inside the while true loop? We're going to increment counter. So we're going to 1 to it through every repetition. And what are we going to do here? Lucky number is counter. So if we run this, see what happens? So while it's less than lucky number, and in this case lucky number equals, when we get to 444, why? Well, when it's 443, it's still less than lucky number. But when it gets to 444, it equals lucky number it is no longer less than lucky number. And so the loop stops counting. Is that fairly logical? Does that make sense? Okay. And lucky number, this is, we're incrementing this before we write it out. So in this case, yes, even though PowerShell is truly counting from 0 to 443, we are displaying 1 to 444. Because once again, this is just another way of adding 1 to make our output more user-friendly. Because the way that PowerShell thinks and the way the human brain thinks, we don't necessarily count the same way. But that's all that's going on there. So does that make sense as far as a while true loop goes, right? It's the keyword while. As with all repetition structures, you put the code in braces that you want to repeat. And then the test condition goes here. So as long as counter is less than lucky number, as long as that's true, we'll keep looping. If that never happened, we just loop forever. Matter of fact, you could do that with a for loop. A quick and dirty and unsafe way, but some people will do this. If I did this, that just creates an infinite loop. And basically that could be used in a fork bomb to cause the system to run out of memory, but that's a quick way to create an infinite loop. And I don't know, I guess if you were trying to code something quick and dirty, I've seen people do that before, but I wouldn't recommend that because there's lots of things that could go wrong with an infinite for loop. But we've left off the initialization part, the test condition part, and the action part, the 3 parts of the basic for loop. We've left it off in this example. I don't know, I was kind of a wild tangent. I just thought of that, but I guess not related to a while true loop. But anyway, you understand what they have in common. The code always goes between the curly braces, the open and closing curly braces. The keyword will be different, so you have for each, while, do while. And in parentheses is always the test condition or portion. And there's also a keyword break. If I could have some decision code inside this loop here, and if I were to add the keyword break, it would also cause it to exit a loop. So that's another option there. Let's take a look at another example. Okay, so this is another type of repetition structure. This is do while. Now, the thing about a while true loop, this condition has to be true in order for the loop to execute at least one time. So if, hypothetically, let's say that for some reason counter started out and it was 444, this while true loop would never execute. Because even the first time in the test, it would say, well, is counter less than lucky number? No, it's not. It's equal to lucky number. Okay, so it's just going to skip the code. And it would just jump down to, whatever code was down here beneath it. So when you're using a while true loop, if you don't care, if it doesn't matter in your script or your code or your logic, whether or not that while true loop executes based on different values, then while just using a basic while loop is fine. But if, on the other hand, you need to make sure that loop executes at least one time, rather than a while true loop, you should use what's called a do while loop. And it changes the structure a bit. Notice in the while true loop, the test condition portion is at the top. It gets tested first before the code inside the loop ever happens or gets repeated. But look at the do while. The do while, the physiology of it is different, right? The structure is different. You have do up at the top, the keyword do. You have your open and closing brace. The code that you want to repeat goes here, but where are we testing the condition? The while's down here, and the condition's down here. So in this instance, even if counter started out at 444, this loop would execute at least one time. So a lot of times you'll use a while true, but in a special situation where you need to make sure that code executes at least once, even if the test condition is not true, then in that circumstance, instead of a while true loop, you'd want to use a do while loop. So if I run this, Notice it does the same thing as the while true loop in this condition. Okay, just counts from 1 to 444, which is, by the way, my magic lucky number. I don't know why it follows me everywhere, but been following me for like 15 years, that number. Okay, but what if we do this? All right, if this were just a while true loop and we did this, it would never execute. But look, it runs one time. So because the test condition's at the bottom instead of the top, like a while true loop, a do while loop will run at least once. But what if we did that? If we did that with a normal while true loop, again, let me show you. So if I set this to be 444, see, it would never execute. So I'm just trying to illustrate the difference to you between a while true loop and a do while loop. I hope that makes sense. And we'll look at a do until loop, all right? Just another option, but I'm gonna do something similar here. Our lucky number is 444, our counter is 0. We're going to do until what? Until counter is equal to lucky number. And if I run this, same thing. Just counting from 1 to 444, okay? So those are some basic repetition structures in PowerShell. And, you know, they all have their uses, their strengths. You know, they're all in different situations where you're trying to code different kinds of logic or control your program flow. They each have their own set of advantages and sometimes disadvantages. So, you know, just think of, as we learn all of these different functions and methods and tools and structures in PowerShell, you're adding tools into your toolbox. And later you'll be able to, you know, the more tools you have, the more things you'll be able to do. Or think of it as adding colors to your palette, if you're an artist, if you're a painter. So instead of having only a few basic colors, you want to be able to paint with more complex, you know, colors in your art and in your paintings and things. Okay?